Yeah, my field is not in epidemiology, but because my interest in applied statistics and in this particular area, and my association with people who have been working in this field, I started working on it, and my graduate student, Bauzi is here, Bauzi Jan, started his master's 3 years ago, and continued on his PhD a year ago. The title here, although it looks long there, it is still short, shorter than what you have in your handout. That's how it started, though. We wanted to look at a correlation between agrochemical residues and drinking water, agrochemical residues in drinking water and bird defects. But while talking to the physicians and epidemiologists, birth defects are different from adverse pregnancy outcomes, and so that birth defect that you see in the title is generic. That's why you see the title negative in your handout. That's going to be our exact title: negative reproductive outcomes. And in addition to agrochemical residues, we also looked at some of the disinfectant byproducts like trihalomethanes and haloacetic acid, because again, one of the great associates, Dr. Paul Winchester, who did a lot of study on this on Indiana data. So just to give you a brief outline of my talk today, I'll start up with a couple of slides showing what prompted this study and to give you the broad objective of the study, go with the steps that we went through to complete the project work, and the type of data compilation. We dealt with both the birth defect data and the water contaminant data. You will see the difference, how we handle and what was the problem we faced with. Then the data analysis. First of all, we tried individual correlation coefficients, correlation coefficient, which develops a correlation one-to-one between one contaminant or one specific birth defect to a contaminant. But whatever that R gives, that is based on the sample data that we looked at. Based on those sample R value, we did a hypothesis testing to check actually the significance, statistical significance of correlation. And finally, we did also multiple regression analysis to look at all these contaminants that we have studied, and looked at all of them simultaneously, because when you look at one-to-one correlation, you miss out on the interaction effects, and that's why we did multiple regression analysis, and we came up with very different conclusions. As part of this study also, we compiled the monthly average concentrations of these water contaminants in the drinking water, primarily to end that particular study we did based on surface water and groundwater. We separated the water sources. This was done primarily to compare with some of the studies that they are doing in Indiana and elsewhere to correlate this agrochemical-based runoffs with the surface-based water resources. And finally, I'll conclude and go to the acknowledgements. 10 leading causes of infant mortality. You can see that the first two there are bad defects, preterm, and low back weight, etc. The first two there, right there, constitutes more than 50% of the leading causes of infant mortality. So that is a different reason why we need to investigate. But when you look into the causes of birth defects, about 70% of the birth defects, the causes is unknown. So that prompted this study, although this study never was designed to develop a causal relationship. We started with this study as a correlation development of some of the key water contaminants, and a future study could be to develop a causal relationship which will be much more comprehensive. Some of the past studies indicated, you can see in that map there, we are right in the middle of Corn Belt, US Corn Belt, Indiana, Illinois, Iowa, so because of the heavy use of fertilizers in herbicides, we will intuitively see a lot of these residues in our runoffs, and that's what has been indicated by many of the past studies. Illinois among the highly nitrate contaminant states. Atrazine was detected in 146 streams out of 149 sampled in the Midwestern states. It was a 2000 or maybe 1999 study. There was a study in Iowa done by Dr. Munger and his associates on the association of atrazine with a specific type of adverse pregnancy outcome, intrauterine growth retardation, IVGR. Indiana study that was led by Dr. Paul Manchester. He's the one who suggested adding, when we initiated this study, he's the one who suggested adding this disinfectant byproducts also and look into their effect, correlation, not effect again. And we are glad we included that, because you will see in the conclusions how heavily the birth defects are correlated to some of these disinfectant byproducts as well. Broad objective was thus to investigate the correlation of incident rates of various negative reproductive outcomes with the concentration of key agrochemical-based contaminants and disinfectant byproducts in drinking water used in Illinois. Negative reproductive outcomes, 3 categories: birth defects, adverse pregnancy outcomes, and preterm births. I will go over the detail of birth defects and adverse pregnancy outcomes in a little bit. But these were the key water contaminants: nitrate, nitrite, and atrazine. Those were the agrochemical-based contaminants. And trihalomethanes and haloacetic acids were basically the disinfectant byproducts. Those were looked into in this study. This is the list of birth defects, again from Illinois Department of Public Health. Dr. Farnoff, Jane Farnoff did a study, and there are 7 different groups of birth defects: central nervous system defects, which is commonly known as neural tube defect, and again there are 6 different subcategories there. In central nervous system itself, cardiovascular system defects, respiratory system defects. So there are, in total, there are about 35 or more different specific birth defects, but they are all grouped for this study in the birth defects category. Similarly, there are about 30 different adverse pregnancy outcomes. In short, I have used APO many times. You will see in the slide. APO means adverse pregnancy outcomes. Again, a different type of APOs are listed there, 7 different groups, and about 30 different individual adverse pregnancy outcomes are listed. We first looked into, we wanted to look at a long period of time, obviously. And 1998 to 2002 was a good best year for comparison purpose, because 1996, I guess they started, the pediatricians started giving folic acid as a supplement to pregnant ladies, and that would have some positive effects. So we wanted to not overlap. We wanted to either go before 96 or after 96, all the years that way, so that we are comparing up and down. we collected this data from Department of Public Health, drinking water data, contaminant data from community water supplies. We tried to collect also data from our private water wells, but we are not very successful. IEPA doesn't have records on those, and we also tried to get some data from Department of Public Health. We got some, but they were very sporadic. So we didn't include them, or we could not independently do analysis on those either because of the limited number of data that we had. So we concentrated on this public water supplies, about 1,800 public water supply we have in Illinois, all over the 102 counties. We first did the correlation coefficient calculation to relate birth defect to a specific water contaminant on an individual basis, and did the hypothesis testing to check their significance, statistical significance, and then to look at, because in real life all these occur at the same time, and so factor interaction is something that needs to be looked into, and that's why we looked at all these 5 factors or 5 water contaminants simultaneously, and evaluated which ones or which factor interactions are actually correlated to some of these specific but negatively productive outcomes. Just to give you an example about birth defect data, which is not very difficult, we checked on the incidence rate, and for a specific county here, this was done for 102 counties, but for a specific county, Adams, we have 7 different type of birth defects listed there, and there were 5 cases of central nervous system defects over that entire 5-year period, 1998 to 2002, and we add all of those cases up. There are 104 cases in total, and the incidence rate we calculated based on 10,000 live births. Okay, and so 249.9 is the incidence rate for birth defects in Adams County. So this was calculated for all the counties and tabulated. I don't want you to go through this, but you can see the first value there is 249.9. That's what was done for all the 102 counties. Birth defect data summary, just to give you this, this information was not used for the statistical analysis. Just to summarize, we had 17,000, almost 18,000, or over 17,000 cases of birth defects during that 5-year in the entire Illinois, in the entire 102 counties. More adverse pregnancy outcomes, 38,000 or almost 39,000. But if you look at the incidence rate of birth defects and adverse pregnancy outcomes, they were not very different. The range, at least, indicating that adverse pregnancy outcomes were occurring more in the more populated area, but clearly preterm birth was significantly higher, about 89,000 or over 89,000 preterm births during that entire 5-year period. Water contaminant data was a little tricky to handle, but this is the way we handled it. Again, example, this is the nitrate data, one of the 5 contaminants we looked at, and one of the 102 counties we looked at. This is Adams County, and we had data for 9 of these community water supplies. And they were measured 20 times. The first community water supply, the second one had 5 different values, so they were measured. Observed values were there in the database of IEPA for 5 different days, and these were the average, for example, this 8.057 milligram per liter was the average of these 20 observations over the 5-year period. Okay? And similarly, 3.36 was the average of the 5 observations that we had. And but then, so there were total 106 observations, and this average value that you see here, 2.641, is actually not an arithmetic average of these. This is actually a weighted average of these observed values in consideration with the population they serve. Okay, for obvious reason, we took some time to get that population data. In the first round, we looked at only the average values and then looked at the population data. And you can see clearly how different it is, because this 5th community water supply serves the most of the people in that county, and clearly then the concentration is heavily biased, and which should be actually, because we are looking at birth defects. And so 2.641 is the average concentration for that county that was considered. And so that was easy. And then detection limit for nitrate, this was not an issue. Based on these detection limits, we had to come up with a censored value. I will, for nitrate, as I said, it was not an issue. But let me go to the nitrite data. You would see that how big an issue it was. For nitrite, our detection limit with the with the equipment or apparatus that they have to measure nitrite, 0.1 milligram per liter is the detection limit. So below that, they cannot detect. Basically, below that, whatever concentration is there will get a 0. Okay, and you can see there, for again the same county, we had for the first community water supply, all 20 observations were actually 0. Okay, so I mean, that's why the observed value is 0. But what exactly was the concentration, we do not know, because it could be anything below 0.1. Okay, and we didn't want to make a judgment on that because there are so many nitrite data was 0. You won't believe we had about I think close to 8,000 nitrite data. 94% or 93% of these data were actually 0. Okay, and so if we just went with the observed value, we would have a 0 here. Again, we didn't want to make that adjustment. So what we did is we had 2 different set of data. One is the observed value, and the other one is the censored value. Censored value is coming, if the detection limit is 0.1, we assume the censored value column gives you the data. So our data is, we are assuming then the concentration is right below 0.1, so we are going with 0.1. Okay? And that's how our censored values are. And that's how you can see a significant difference in the censored value average and the observed value average. In fact, in the entire nitrite data, this was there. You can see the individual values there. The values very small in milligram per liter, but if you look at the magnitude of the difference at 10 times, 100 times between the censored value and the observed value. And that is why essentially we wanted to have 2 different data sets for future, because definitely this study will be used in future. And we do not know exactly because of the measurement or lack of precision at this point. And that's how we ended up with 2 different data sets for all those water contaminants. It was not very different for trichloromethanes or haloacetic acids. And but for nitrite and also to some extent atrazine, it was also very different. You can see just from the range values here for the nitrite 0 to 1.19 was the observed range, whereas the censored range was 431 to 1274. And similar difference was there also in the nitrite data. As I just mentioned, we have about 9,909 nitrite data, but only about 7% of those data was non-zero. Okay, so those were not censored data. Those are the real observation non-zero data, and so that could be considered as a detection frequency. For atrazine, also that number was very low. It was only 12%. But for others like dihalomethanes and haloacetic acid, it was over 90%. And that's why you do not see any difference in their observed and censored data. If at all, it is very minimal. So in nitrate case, we had about 60% of the data. Actually, only 40% of the data were censored because of the zero values there. But that last column gives you an idea about the maximum level concentration level allowed, and you can see the range also. You can see some of these dihalomethanes actually are above the range or above the maximum concentrated level. I'll make a point about that later on. The first correlation analysis that we did was the Pearson coefficient of correlation, which is calculated using expression like that, R, and all the YIs are basically the rate of negative reproductive outcome for each county. Those could be your birth defects, adverse pregnancy outcomes, or preterm birth. And XIs are individual contaminants. Those could be any of those 5 water contaminants that we looked into. Once we determine R, of course, it is instructive to realize that this is a sample correlation coefficient based on the 5 years data that we have. And so we did a hypothesis testing to check whether this correlation is significant or not statistically. And there is a table here, summary table for one of the correlation coefficient for nitrate that we developed for ED, by the way, is birth defect. APO there is adverse pregnancy outcome. ED is preterm birth. These were the p-values that was calculated, and the critical p-value was 1.294, and the only values corresponding to the birth defect was greater than the critical, and that's why that was the only productive outcome, negative reproductive outcome that was considered to have a significant correlation with the nitrate. And that's how we developed for the other contaminants as well, which are summarized here. Again, as I said, we had 2 different data sets, observed and censored, specifically because of nitrite and to some extent atrazine. And you can see that in nitrite data, based on the observed data, nitrite not developed. There was no correlation based on preterm birth with nitrite, but when you look at censored data, there was a correlation. And of course, we are not sure which one is true, neither we want to guess, but at least that's what we saw. One of the interesting things that we see here is not very many. I mean, you see birth defects are correlated with nitrate, okay? And also you see birth defect is correlated with haloacetic acid, but you do not see them being correlated with any of the others, okay? When we looked at this way, that was our finding. And similarly, adverse pregnancy outcome was only correlated to nitrite data, whereas it was not correlated to any of the other contaminants. But that conclusion changed quite a bit when we went to the multiple relation analysis, where all the 5 contaminants are considered simultaneously. And this was a example table again. It was a backward elimination regression. And some of the points, I don't want you to go through this, but some of the points I wanted to make here is all the 5, X1, X2, X3, all those contaminants were considered, and a polynomial model was hypothesized. Total R squared, you can see, so of 35.76% or 35.8% of the variability, you can say, is can be explained due to these explanatory variables that we have here. And then after about 14-15 steps, we were able to get rid of all of the non-significant factors and ended up with the statistically significant factors. You can see this is for adverse pregnancy outcome. It is not just related to nitrite, which is X2, it is also related to its, most of those, I will summarize in a little bit, but most of those contaminants are correlated with adverse pregnancy outcomes. And similar, this is a summary table for all of those different type of negative reproductive outcomes we looked at. Again, there are 3, and you can see 2 different sets of data for each category, because we looked at observed and sensor data separately. And so this gives you the significant main factors. The last one column, and this one here is significant factor interaction. What happens when nitrate is present, and how nitrate affect, or nitrate interaction, how it affects the birth defect. And then we also, as I said, we looked at the month-wise concentration of various specific water contaminants. Atrazine has been, this was also our finding here, which was very strongly postulated by several investigators all over the world. May-June effect with atrazine, because here we have been able to isolate the surface water-based data and groundwater-based data. These are not surface water data, by the way. These are from the community water supply based on surface water. And so you can see clearly the May-June effect for atrazine. In May and June, the hypothesis has been that atrazine peaks in May and June because of the runoff and because of the significant rain during that time, and runoff from the agricultural field and all that. And one other thing you can see here is also the concentration of atrazine is higher, actually significantly higher in the surface-based community water supplies. That is also another thing you can see in all the 3 agrochemical-based contaminants, atrazine, nitrite, and then these last two are your disinfectant byproducts, trichloromethanes and haloacetic acid. These are, by contrast, they are more, their concentration is more in the groundwater-based community water supplies. I do not know why it happens, but that's something that the data indicates, and we have to find out more about that. We have developed some hypotheses, but it's just a hypothesis. Similar findings was also there for haloacetic acids. In conclusions then, as much as 16.3%, almost 36% and 20.6% of the variability in the rates of birth defects, adverse pregnancy outcomes and preterm births is explained by 5 different water contaminants that we looked into: nitrate, nitrite, atrazine, trihalomethanes, and haloacetic acid. And again, it is in public drinking water supplies only because we didn't have enough data to look into the private well. And one other thing I must point out here is correlation doesn't mean causal relationship, but correlation is the first step that has to have for a relationship to occur, causal relationship to occur. So with these findings, it can lead to, that's one of our recommendations for a more comprehensive study. I'll get into that in a little bit. The two disinfectant byproducts, which we included actually based on Dr. Winchester's recommendation, trihalomethanes and haloacetic acid, they are significantly correlated, their correlation with all the 3 categories of negative reproductive outcomes that we looked at are statistically significant, and so is also nitrate. Nitrite, surprisingly, was not significant for birth defects, although it was significant for adverse pregnancy outcomes and preterm birth, but it was not, at least at a 80% confidence level of alpha 0.20, we could not relate the nitrogen to the birth defect. Atrazine is significant for all 3 categories of negative reproductive outcomes, except the birth defect model based on the sensor data and preterm birth model based on observed data. For the monthly average concentration for all 3 agrochemical-based contaminants are much higher in surface water-based community water supply. Concentration of disinfectant byproducts are more in the groundwater-based water supplies. Atrazine concentration peaks in the month of May and June, which agrees well with the past studies. And the peak monthly average concentration of trihalomethanes are well above the corresponding maximum concentration limit. That's something definitely alarming. In fact, 10% of all the observations that we had, 10% of the data indicated these measurements being higher than the maximum concentration limit. I'm sure somebody is doing something about it. Peak concentration of haloacetic acids, also the same way. They peaked in May and November, 75 microgram per liter and 100 microgram per liter were the peak concentrations, and that was way above the maximum concentration limit set by the EPA. And the recommendation based on these later findings, surface water-based community water supply and groundwater-based community water supply were separately examined, because we saw the concentration of agrochemical-based contaminant in surface water-based systems are higher, and for developing meaningful correlations on the individual birth defect, like maybe central nervous system, or even one of those central nervous system type of defect, you need to look at a lot of a much larger database. 5 years was not enough. We wanted to be actually looked into, but we didn't have, for example, you saw that I think in the county we looked at Adams County, there are a total of 104 cases of birth defects in the entire 5 years. For some of the specific birth defects, there are only 1 or nil in that entire 5 years. So if you want to really correlate some of those to some of these water contaminants, you have to have a much larger database. A much more comprehensive, this would be the final goal of this future goal of this study. A much more comprehensive study using controlled experiment in future should include all known factors contributing to various negative reproductive outcomes, to develop predictive models for each, which is wishful thinking, but at least some of them, some of the important birth defects and adverse pregnancy outcomes. If we can develop a predictive model, that's where the cure will come, so that's the ultimate goal. With that, I would definitely acknowledge the help, financial help of the Illinois Sustainable Technology Center, or WMRC, which used to be when I was approved this project. Dr. Paoli I'm glad to see him here, although he has retired from the center. He's the one who was instrumental in putting me in touch with people in Illinois EPA, people in the right people in Illinois Department of Public Health to form a group so that we can do this study. And over the year of the project, definitely Nancy and Dr. Rajagopal here helpful, and Kerry Arnold and David Duguid from USGS Champaign in their water division. They were very helpful with the studies. Illinois Environmental Protection Agency, that's where we got all our water contaminant data in several cycles. And Jerry Long is the person. I have never met her, but I have talked with her and communicated with her several times. She was very kind. And Illinois Department of Public Health, Dr. Pornoff, if some of you know her, Chris Wilson and Lloyd Evans, they were very, very powerful with data. Indiana University Medical Research Center, that's where Dr. Paul Winchester is. He's a neonatologist, and I'm still in touch with him. He's on board about this issue, and we are trying to expand this study to some future more comprehensive studies. With that, I'll take questions. Yeah, please do it. No, I'm sorry.
Not using private, or not somehow allowing the private well, private well water consumption probably isn't important for Cook County.
It's not.
But downstate makes it very difficult. You're not going to have any disinfection on products.
Yeah, obviously it won't have because it doesn't go through a treatment process. But do you have, I'm really glad you mentioned that, because I was trying to get some information about the split. For example, you said downstate private well and community water supply. Do you have some information, at least overall Illinois or some state, about what percentage of the people
Well, if you have the percentage, so what?
No, if you have the percentage, you know. If you're doing a study, at least it's geared towards 90% of the people.
Can I ask a question?
Yeah.
Does the Department of Public Health, their data on negative reproductive outcomes, is that split between community water supplies and private water supplies? Do they have any sort of?
No, that is unfortunate. No, that is, see, that's why we had to, the way, because the data came from two different agencies, Department of Public Health had all the data based on counties, all the counties, but they don't have any data around a community water supply, which is fortunately there for EPA. If you dig into, you can find each community water supply, they have a number of people served by that. And,
but this whole other sector, we don't have any data about it.
Right. For private well, I would really like to, I will be in touch with you, actually, if we can find out some more. I have some private well data that I can share with you, but these are so sporadic. I mean, you cannot just use it for any meaningful conclusion.
Just a quick point of clarification. What was your confidence interval for determining a statistically significant correlation? I thought I heard you say 80%. Is that right?
Yeah, alpha was 0.2.
That seemed like a rather generous.
Yes, rather generous, but even with that, we could not establish in many cases. That was for, but we didn't base many of our conclusions on that study, but I will go ahead and say.
I think the difference we're looking at here is the epidemiological data versus the kind of data we're used to working with.
Right.
We're expecting correlation versus one we just kind of keep it in the dark.
Really observational data. Yeah, you are absolutely right. This
Are
is
there
very
any,
generous.
did you go ahead and calculate the actual p-value of the correlation? So are there any that are actually maybe 99.99%?
No, there was none.
Okay.
The best I got was 93%.
With?
With one of these, I do not remember, but I can share that with you. And but this was, look, this was the finding. I mean, we even at that level of generosity, we could not correlate it, but the effect with say nitrite, with atrazine, with trichloramethane, and our conclusion is. Looking at this type of correlation one at a time is not the best because in reality actually all of them occur together.
Have you considered, just for an alternative source, using water data from a non-agricultural state, just to try to compare?
That's a good point. I was thinking about it. Not yet. We haven't done anything, but we should do that. Do you have any access to?
No.
Okay.
No, that's.
Yeah, that's a good point. Because then we will get some feel what's going on, because we are saying all these agrochemical are creating problems. Yeah, that's good.
Is there, I mean, are these conclusions consistent, what is medically known about that chemicals? Anything known about it?
I have medical. I mean, I have shared these results with Manchester, and but I haven't had a discussion with them. But that's something that we need to pursue.
I'm wondering if they know medically what causes what or.
Right. No, medically they don't actually. They can consider as a cause. But they're all there. If you look at Manchester's data, they show all these trends about the higher concentration of atrazine going well with higher in those periods. May, June, apparently they see more number of people.
What about data relating to, say, animal studies or?
Animal study has shown for atrazine. Animal study has shown in the case of the frogs, it has really shown some effect on health. Techniques of the reproductive system. But not on human beings. It depends on the right of animals, nitrate, and atrazine.